So we're starting a new unit, which is the rational functions, and then investigating those rational functions and graphing them. The first lesson is about looking at reciprocal functions and looking at the characteristics of these reciprocal functions. So first thing, let's describe what a reciprocal function is. So a reciprocal function is when you have a function. So let's say, I don't know, y equals x plus 5. A reciprocal function would be 1 over x plus 5, right? So these are reciprocal of each other. Now, so we're going to describe what is the relationship between the characteristics of f of x graph and its reciprocal 1 over f of x graph. These are some examples of reciprocal functions. So we need to look at the zeros, the y-intercept, vertical asymptote, behavior, and behavior horizontal asymptote, increase and decrease, and then point where the two graphs will meet. So first of all, if you have the function, right, if your denominator is equal to 0, so you have the number, which is 1, for example, and then you're dividing by 0, that's going to give you an undefined answer, which gives you your infinity. So basically, that's your vertical asymptote. So the vertical asymptote is whenever the denominator is equal to 0. Versus if you have a number and then the denominator is infinity, you get a 0. Okay, so these what would give you your zeros. So in general, if you have 1 over f of x, so whatever f of x is equal to 0, the reciprocal will have a vertical asymptote. So the zeros of f of x are the vertical asymptote of the reciprocal function. The vertical asymptote of f of x, if f of x has any vertical asymptote, they will be the 0 of the inverse. So what we saw here, right? If you're dividing by a very infinite number. So if though f of x have vertical asymptotes, depending on what kind of function it is. So the vertical asymptotes of f of x will be the zeros of 1 over f of x, or the reciprocal function. If the end behavior of f of x is y approaches positive or negative infinity, then the end behavior of 1 over f of x, so this is more like this, right? The end behavior of 1 over f of x is y approaches 0. Okay, so basically if you have your original function looks like this, your reciprocal function is going to be approaching 0. Okay, so it's going to be something approaching 0. All the y values of f of x become 1 over y, because I'm looking at 1 over f of x. So for example, if you have, let's say, a point, and the point is 0, 5, then the reciprocal point will be 1/5. If f of x is increasing, on the interval, then 1 over f of x is decreasing. The only place the two will meet at positive and negative 1, right? Because the inverse of it, think about it at y equals positive and negative 1. Because think about it this way, whatever the x value is, if this is 1, the reciprocal is going to be 5 and then 1 over 1, so it stays 1, right? So no matter what you do, when you flip it, the 1's going to stay 1. Okay, so we're going to try to sketch the reciprocal of the graphs given those graphs. Okay, so the first thing that you're going to do, you're going to start by placing your vertical asymptote. So whatever you have an x-intercept, that becomes your vertical asymptote. Okay. And then you're going to locate the points, which are the ones that have a y value of 1. So this y value of 1, this y, or negative 1. So these y values are going to stay the same, you know, these points. We know that if it's increasing, that means the inverse is going to be decreasing. So my function is going to be decreasing here. And we know if it's going toward infinity, my end behavior is going to be towards 0. So that kind of explains my values. Now let's pick some points here. So if the point here is negative 1.5 and 2, my next point is going to be negative 1.5 and a half. If it's negative 1 and 3, it's going to be negative 1 and 1/3, right? If it's this point here, which is at 1/2, it's going to be at 2, right? So your graph is going to look something like this, where it's going to approach 0, but it's never going to equal to 0. Because we know 1 divided by a very, very big number is close to 0, but not equal to it. And the graph here, again, my end behavior is going to be going towards 0. And then it's going to be bound by this vertical asymptote. Okay, so if you have x-intercepts, you locate your vertical asymptote first. You locate any points at 1, and then you start finding some points by flipping their y value. So in this case, I have no vertical asymptotes, right? Because I have no x-intercepts. I have no values at 1. My end behavior are going to infinity. That means my other end behavior are going to be going to 0. Therefore, the reciprocal. I'm going to take this point, which is the vertex, and I'm going to say, okay, the vertex is negative 1, 2. So my reciprocal is going to be negative 1/2. And then I could take another point, which is at 3, negative 2, 3. It's going to be negative 2 and 1/3. So your graph is kind of like going to be like this. And since this is decreasing, my function is going to be increasing. My reciprocal is going to be increasing. And since this is increasing, my reciprocal is going to be decreasing. Okay. Now, if the equation is given to you, you would want to sketch it. You would want at least your vertex. Now, this is not in vertex form, so we have to complete the square. Put the first 2 terms in bracket. Take out the 2. Even I'm going to get fraction here. We're going to take that base, we're going to square it, and then we're going to divide it by 2 first, and then we're going to square it. So that's going to be 1. We're going to add 1 and subtract, actually, negative, 0.5 divided by 2. That's not right, that's not 1. 0.5 divided by 2 is 1/4, and then 1/4 square is 1/16. That's the number I should be adding and subtracting. Now we're going to take the 1/16 out. We have to multiply it by the 2. And that's going to be x squared minus 1/4, actually x minus 1/4 to the power of 2. And those are going to be added together, so that's going to be plus 7/8. Okay, so my vertex is 1/4 7/8. Now to graph this, that's going to be a positive and this is going to be a negative. And then it's going to open up. Now for the reciprocal, the point is going to be the reciprocal of 7/8 is 8/7. So it's right here. Now this side is increasing, so the other side is going to be decreasing. Again, you have no x-intercepts, no vertical asymptote, and you know your end behavior is going to be this. Same on this side it's decreasing, right, if I'm moving from left to right. So that means my inverse or reciprocal is going to be increasing. So if I look at this increasing, get to this point and decreasing, versus decreasing, get to this point and then increasing. So they're opposite of each other. Okay, so you always have to try to factor and then try to find, try graphing your original function depending on what form it's in. So if it's in vertex form, if it's quadratic, then do vertex form. If it's something else, just factor. I can factor an x out here, so that's going to leave me a negative x, so that's going to leave me with x squared minus 9x minus 8. Can find two numbers, I'll multiply to negative 8 and add to negative 9. I probably can't. So I'll do the quadratic formula. If I do the quadratic formula, I end up with the two zeros that are 9.8 and negative 0.8. So I can put them in the equation. I'm recording. So once you find your x-intercepts, you can now graph my x-intercepts are negative 0.8, 0, and 9.8. And the graph is going to be going from the second quadrant to the third quadrant. Okay, so this is my original function. Now to draw your reciprocal, you're going to have to locate your vertical asymptotes. And then we remember that the end behavior are going to be approaching zero. So we can put that as a horizontal asymptote. We'll talk more about the horizontal asymptote after. You see this is decreasing. So in that part, since the original function is decreasing, then the reciprocal is going to be increasing. In the part here, we have decrease, then increase. So the function is going to be increase, then decrease. Now, it all depends on what this point is, which we don't know what this point is. Okay, we're just going to sketch here. Okay, we're not 100% sure. If you're looking at this one, it's going to be increase, then decrease. So the inverse is going to be decrease, then increase. And lastly, in this part of the graph, we have a decrease, so the reciprocal is going to be increase. Okay, so we have a sketch of this graph. Okay, so again, you locate your vertical asymptotes. If your end behavior are going toward zero, toward infinity, then right away you know that your new end behavior are going to be going towards zero. If the function is increasing, then the reciprocal is going to be decreasing. Actually, I do have a point here, which is this -1. Your vertex here is 0, 5, so it's going to be 0, 1/5. It's increasing, then decreasing. So because it's increasing and decreasing, it's going to be the opposite. Make sure that you locate those 1 points. Okay. And then the last part is if the function is decreasing, then the reciprocal is increasing. And that's your function. All right. So I will include the answers for all of these, okay? Just this is basically what the lesson is all about.